Okay, so we're going to get started. You guys got two handouts today. One is exercise 212, which essentially directly relates to assignment 202, which you also got today. And so for assignment 202, you're going to be making a physical topographic model. Yeah, I have a few of these that you can pass around that are kind of sending back so you can get a sense for how these work and what you're going to be creating. The important thing here is that I want you to be able to get a surface that you work with and manipulate in Rhino into some kind of physical form. And so for this assignment, we're going to be working to create these kinds of layers that we would glue together to build something like this. The next assignment, you'll end up doing the 3D print. So you'll get the experience of 3D printing an object. So the goal is for you guys to get that experience over the course of the semester. This particular assignment, if you understand it and you work with it well and you become comfortable with it, will pay huge dividends down the road as you work in studio. To be able to quickly create a nice topographic model is great. And when they look good and they come together nice, they make your physical model turn out really nice. When you move on to Berkeley, they will make you do stuff like this, and people will spend hours and hours and hours doing it. It's so not worth spending hours of doing it. If you understand the method and you understand how to work with Rhino, you can create this really fast. So for somebody like me, I could probably start and finish within an hour on one of these models. So they're supposed to be really fast. The first time through, it's going to take you days, but that's okay. It's your first time through. The point is that these, if you work at them, they'll become really fast and really easy to work with. And so anyway, I'm passing a few of these models around so that you guys can see physically what we're creating. The other thing about this kind of a topographic model is because it's hollow on the inside, it's very, very efficient in the use of material. So you guys will have to buy some cardboard for this, but my guess is that you will only have to buy 2 sheets. You really only need 1.5 sheets. So if you have a friend and you want to share the 3rd sheet, so you each buy 1.5 sheets, all the better. So it's very efficient. Some people build topos and they stack layers and layers and layers of cardboard together, which takes a lot of cardboard and is very heavy. There's no reason to do that. You can get away with something like this. So we're going to be going through the steps to create this. I'm going to walk you through it. The steps involved will go over the next 2 class periods. So I'll go through it today once, and then I'll go through the end of it. So I'll get through about half of it today. And then next class, I'll go through the whole thing as if I hadn't done any of it. So you'll see the whole thing through. Likewise, what I do today will repeat what we did last class a little bit. So you'll kind of be able to see that process. So I'm going to go ahead and send this one down. Oh, you guys are already passing around, so that's good. OK, so as we get started, first thing we need is a piece of terrain or a piece of topography. Like I said, I'm going to repeat myself from last class just a little bit. In that, I'm going to get my get my topography from SketchUp. So I'll open up SketchUp 2018. That's what we have on these computers. And once it's opened, I'll go into template, and I'll make sure that I'm in architectural design feet and inches. Though you could be in the simple template feet and inches. It really doesn't matter. You just want to make sure you're in feet and inches. And I'll start using SketchUp. And then I'm going to go to the File menu, and I'm going to go to Geolocation, Add Location. And I would recommend that you pick some piece of terrain that is reasonably interesting. I've had people in the past do extremely steep pieces of terrain. If you think about steep pieces of terrain, it involves lots of little tiny slivers of cardboard. If you think of something too flat, it's not very exciting to do. So somewhere in the happy medium. There's one with a bunch of valleys on it that's pretty neat looking that is complex enough to have interest, but not so much that it's really hard to build. So once again, I'll pick a Mount Diablo-ish example. So I'll zoom in here. Once I have the size that I'm interested in, I'll click on Select Region. It will only let me take up to that amount as my maximum region. That's fine for our purposes. The other thing that you'll find when we build the model is that the scale that you're building the model in will change dramatically for each of you. And I'm going to allow you to pick whatever scale you want. Typically, in an assignment, you'd be given, I want a model at this scale. And so for our purposes, I'm not going to tell you that. It just needs to be big enough. But if you pick an area of land that's smaller, your scale is going to be bigger. No big. So I'll go ahead and click on grab, and I will get the terrain. Yeah?
Could we potentially use the terrain we used last class? Or
Yes, you absolutely can. But I'm going through it as if you were starting from scratch for the practice of you seeing me do it over and over again. OK, so there's my terrain. If I went to File and I went to Geolocation, Show Terrain, I should see the terrain. So there I am. I can see my terrain. OK, I'm happy with it. At this point, I will go to File and do a Save As. And I have to make sure I go back in time a bit. So we'll go back to a SketchUp version 2013. And I will save this on my flash drive for today. And I'll go ahead and save. There we go. I'll go ahead and close SketchUp now. I don't need it anymore. And I'll open up Rhino. I'm going to choose the large object inches template. There we go. And once Rhino is open, I'm going to go ahead and go to the File menu, and I'm going to go to Import. I'm not inserting a block. I'm actually importing something. So I'll go to File and then Import. I need to go to my flash drive and find that file that I just saved. There it is. I'll go ahead and open it. We'll bring it in as a mesh. The rest of those default options are just fine. And now it's come in. I don't need the little person, so we can get rid of her. And let me look at the terrain that came in. I will also go into shaded mode so that I can kind of see it. I'll take the terrain and put it on its own layer. And we'll call that SketchUp. Maybe SketchUp terrain. So with it selected, I'll right-click on that layer and say Change Object Layer. Now it's on that layer. That's the only piece that really matters. The rest of these can get turned off. And just like last time, I have to convert this surface into a NURB surface, into a Rhino surface, so that I can actually start to manipulate it and work with it. So just like last time, I'm going to use my contours in X and Y. So I'll start with layer 1 here. Yeah?
What's that file you saved from SketchUp?
2013. SketchUp 2013. So under layer 1 here, I'm going to rename this to be Contour X. And I know I'm moving through this a little bit faster, but I'm assuming that you guys did it last class, so it should be rather easy. Layer 2, I'll make Contour Y. There we go. Let me make Contour X active. There it is. It's the active layer. And now I need to contour that surface in the X direction. So I'll go up to my curve, curve from objects, and then contour. Contour base point, I'll pick that corner. I don't have any snaps turned on, so let me turn on my object snap. And I'm going to use the vertex object snap to get the end. There it is right there. And I'm going to make sure that I turn on ortho and just go off in space in this direction such that I'm not snapping to anything. It's very important to be on axis. And then distance between the contours, I'm going to guess at about 100 feet. Looks pretty good. I've deselected everything, and I'm going to move over to the contour Y. I'll double click on contour Y, and we'll come back and go to my curve from objects, contour. I could also type in contour. I'll select my surface. I'll press enter. My base point is the same point. This time I'm going off in the Y direction. And it will be once again at 100 feet. And I'll hit enter. And it'll create that piece of surface. At this point, I can turn off the SketchUp surface altogether and just look at the mesh that I created, the network of curves. So there they all are. In order to do the curve network, to actually convert this over into a surface, I need to do a trim. I'll do that in the top view. And I'll do a trim. I can be rather generous, so we'll select in just a little bit further to make my life a little bit easier. Remember, if you accidentally select something, you can use Control to deselect it. I'll type trim or go up to edit and then trim, or you can select the trim tool. Any of those are fine. And I'll trim off all these extra pieces. And there we go. One extra piece over there that needs to get deleted. It's gone. Now I have this in a perfect grid. It's time to convert this into a NURB surface. So before I do that, I'm going to come over here to another layer. I'll double click and I'll rename this just plain terrain. I'll make that the active layer. There it is. And then with all of these lines selected, only the lines, I'll go up to my surface menu and I'll do a curve network. Alternatively, I could type network SRF into the command line to initiate this command. This is normal to say that it has more than 100 curves. That's fine. Yes, we want to continue. If I did it correctly, I should get 4 sides, A, B, C, and D. The rest of these values are all fine. I'll go ahead and say OK. And we have to let it work for a little bit. Remember, this can take up to a couple minutes to do its processing. OK, so I was able to create the surface. Remember, Rhino runs really slow after you create this. So I'll click off so that I have nothing selected. Then I'll click on again until I get the solid yellow selection. There it is. Now I'll go into rebuild. I can type rebuild or go to edit and then rebuild. And I'm going to simplify that surface. So we're going to go from its current values to, I'd say, 100 by 100. There. I'll go ahead and say OK. And once I finish that, Rhino gets a lot faster to work with. I'll turn off my contour X and contour Y. And now I'm back to having a nice NURB surface to work with to start to create my model. So this is approximately where you got last class. We did a little bit more. We took it a step further. But essentially, once you're at this stage, we're ready to start thinking about the model as a whole. OK? So the first thing we need to do is we need to understand what scale we're going to be doing our model in and how large the physical model is going to be. So as part of the assignment, I'm asking you to create a physical model that's 11 inches by 17 inches. So that's the one that was passed around. It's 11 by 17. It is convenient for fitting on the laser cutter. That's why I picked that as a size. So I need to figure out how to make this fit on an 11 by 17 sheet. But I also need to understand that this is at full size right now. It's really big. So how do I go about figuring out what scale is appropriate? Now, in a traditional studio setting, like I said earlier, your instructor is going to say, I want a model that's at 1 to 200. Or I want a model that's at 1 to 100. Or I want a model that's a 1/4 inch equals a foot. Or whatever. They're going to tell you what the scale is. For our purposes in this class, we actually don't have a scale that's assigned to you. It's just whatever scale fits nicely for this particular piece of terrain. So you'll notice at the bottom of the handout that I gave you, it's also available online on the course website in today's exercise. There it is. I have a chart. And this is the topography creation cheat sheet. It makes your life a lot easier, though there's a lot of information on it right now. I actually have it open in Photoshop so I can highlight a little bit, and you guys can hopefully see it a little bit better. So over here in this first 2 columns, there's a text for selecting the scale. So we want to start by selecting the scale. I have drawing inches and actual feet. Essentially here, what we're looking at is, are we doing a scale at 1 to 500, 1 to 250, 1 to 200, etc. As you come down here, this lower section right there becomes the architectural scales. So there's a 1/4 inch equals a foot, for example. A 1/16 inch equals a foot. So there is some repetition in this lower section. It just depends on whether you're working in more an engineering scale, large scale, or whether you're working on a little bit smaller scale. So I have those written out here as well to help you guys should you end up having to pick one of those other scales. For our purposes, chances are we're going to be at 1 to 500, 1 to 250, or 1 to 200. That's my guess as to the scale that you'll be working in. I'm picking, for today's example, 1 to 250 as my scale. I will confirm that it works a little bit later on. So if I'm picking 1 to 250, that's where I start. As I come over here, I'm going to look at a few values. So first off, I have the laser cutter size, just so that we know how many feet by how many feet that would be. But I'm going to look here at the 11 by 17 size, right there. And what 11 inches is at 1 to 250 scale, it's 2,750 feet, right there. 17 inches at 1 to 250 scale is 4,250 feet. So when I come back to my Rhino model, right here, the final model at 1 to 250 scale should be 4,250 feet by 2,750 feet. So in Rhino, I'll come over here. I'm going to do this in the top view. I'm going to draw a rectangle right here that is 2,750 feet. So let me say at 2,750 feet. Notice I have to put the apostrophe in because it's in feet, by 4,250 feet. And I'll go ahead and hit enter. That then is the size, the 11 by 17 size of my final model at scale. If I turn on my shaded mode in this top view, I can kind of see what the topography looks like, and I can move this over the top of my terrain. I'm not going to use all of the terrain, I'm just going to use a piece of it to get to this particular size. Now, it would be nice if I spent a little bit of time and thought about what part of my terrain is attractive, which part do I want to keep. This upper corner has a nice little hill in it, so I'm going to move that towards the upper corner. So let me do a move. I'll move this over like that. Sometimes you have to look at it in the top view to make sure, oh, I don't want to miss anything. There it is. So that rectangle there is representative of the size of the final model that I'm going to be creating. If you did that and you put in the same feet that I did in the 1 to 250 scale, and your rectangle hangs off the side, for example, you need to pick a different scale. There is no reason that you guys have to pick the same scale that I did. This is just the example one. This is the one I picked. I could do a smaller scale. I couldn't do a larger scale. 8,500 feet by 5,500 feet wouldn't fit in this model. So if I did something at 8,500 feet, 5,500 feet, and we looked at it, nope, it's definitely too big. So I wouldn't do it at that scale. OK, so now I need to shrink the size of this terrain down to just the size that I'm going to ultimately be making. So I'm going to use the project command to do that. We've done this before. In the top view here, I'm going to use the project command. It's going to be under curve, curve from objects, project. First thing it asks is to select the curves. There's my curve. I want to make sure that I'm in the top view when I do this, however. And I'll hit enter. Then select surfaces and polysurfaces. There's my surface. And I'll go ahead and hit enter one more time. At that point, my rectangle, that was the correct size, now goes and follows the terrain. So you see how I changed that from being a flat rectangle to being something that follows the terrain. And now that I've created that, I can actually trim off the extra surface that I don't need. So we'll go into the trim command. I could use the trim button. I could go to edit trim, or I could also type in trim. Select object to trim. There it is. And now I'm down to having just the piece of terrain that I'm going to create my model from. So let me zoom, followed by S for selected, so that I can orbit around this particular object. That is now the surface that I'm going to create my piece of terrain, the cardboard model. So what I did was I started with my big piece of terrain. I went to the little cheat sheet. Sorry, wrong one. I selected my scale. I found out what size 11 by 17 would be at that scale. I drew that rectangle and then projected that rectangle and ultimately trimmed the surface to be that size. So now I have it. That's good. Now that I have this particular piece of surface, which is the goal, I'm going to go ahead and slice this particular piece of surface up such that the contour intervals are going to match the thickness of the material. So this is really important to understand as part of this context. So I have the size set. What I need to do now is in the physical model that I'm making, I need to have a very accurate measurement of what each of these steps is going to be. And so this is not based on some arbitrary number. I'm not picking, oh, I want to contour every 5 feet or whatever. I need to actually know how thick the cardboard is, the material I'm making the model out of, so that I could figure out what the contour interval should be. And so the next part of this big spreadsheet here is contour material thickness, right here. So I have a chart that goes all the way from a 1/16 of an inch up to a 1/2 inch. The idea being here, if you were doing a very large model, you might be doing it out of plywood, in which case you'd be at a 1/2 inch or a 1/4 inch in plywood. If you're making it out of the bookstore cardboard, which is what this is, if you measure it really carefully, it looks like an 1/8, but it's actually just a little bit bigger. So we're going to be in the 5/32 category. So it's important to be accurate when you measure it. Really be accurate. If anything, make your contour interval, your contour interval should be a little bit greater than what you're measuring because you've got glue in between. So it's better to be a little bit bigger than a little bit smaller as you think about it. So we're going to work with 5/32. I'm assuming for now that you're going to be using the material that's out of the bookstore, which is this brown material here. And once I've selected that it's going to be the 5/32, I'm going to come down into my column and I'm going to find out what the contour interval is going to be. So it's this number right here, 39.063, and this is in feet. So I need to cut my contours in the z direction every 39.063 feet to be the same thickness as these little contours. So now that I have that number, I'm going to come over to this. I'm going to go into my contour command again. So I'll go to surface, curve from objects, contour. Contour base point, we're going to pick right down here at the bottom. I am going to turn off vertex and turn back on endpoint so I can get that corner. And now my direction perpendicular to the contour planes, that needs to be going up straight in the z axis. So it's not in the x and not in the y. In all likelihood, I'm going to have to come to one of the other views. There it is. I'm going to make sure it goes straight up and down. And I can verify that by looking in the front view and in the perspective view that it's going straight up and down. Right there. I'll click. Distance between the contours. Here we go. 39.063 feet. And I'll go ahead and hit enter. That is then going to divide up my surface into intervals that are the thickness of the cardboard I'm going to make my model out of. So now that I have that, right, I should really have put those on a different layer. Let me change them to layer 4 here. Change object layer, and we'll call this contours, for lack of a better term. I'll make it active, and I'm going to go ahead and turn everything else off. So I've left myself with just these contours. I can confirm that they were done correctly by looking at them in the side view, either the front or the right side view. And when I look at them, they should be perfectly horizontal. That's good. That's what I want to see. Same thing in the right side view here. They would all be perfectly horizontal. All right. So at this point, we have to start thinking about the sides of the contours. So if you look at the model that I passed around, see how the side has a bunch of little steps on it? We have to create the curve that represents all those little steps. And so there's two different strategies for doing this. I'm going to show you both. One strategy on the surface seems a whole lot easier, but long term it's going to be a little bit harder and take more time. The other strategy, which initially is harder, is going to end up being easier if you understand the concept. So I'm going to show you both methods for creating the stepping sides. After I create the stepping sides, we're going to stop for today, and then we'll come back and do the whole thing again next class. So I will do everything that I just did one more time next class, so you can see me do it one more time. Because I believe that this is something that's very, very important for you to do. So, okay, I'm going to work on creating the stepping sides, and this is what's going to take the bulk of your time today, is to work through these stepping sides. So I'm going to start trying to think which side. I'm going to start on one of the shorter sides. I'll do this side here, and I'll do the first method. So the first method for doing this is I'm going to create points on every end of these lines. Actually, you know what? I might do it here. Well, either way, it's complicated, so that's fine. So I'm going to create points on the ends of all of these lines. So there's a point tool over here in the toolbars. I'm in the standard tool set. There's a point tool. This is a single point. So if I do this, I have to put the point on, and then I have to hit enter, or then I have to right-click to start the command again and put the next point on. Below this is a multiple point tool, or excuse me, if you right-click on it, right-click on it, it'll create multiple points, in which case you can essentially walk your way up with the endpoint snap on to all of the ends of these pieces. So I'm just snapping to the end of all these pieces. Pretty good. And so I make sure that I get all of the points on the ends. I can confirm this by looking in the top view and making sure that I got all of the ends of all of those points, which I did. That's good. I'll hit enter to finish, and now I have all of those points. The next thing that I'm going to do is I'm going to start at the first point here. Actually, I'm going to select all the points. And I really should have put the points on a different layer. Because I didn't, I'm going to do SELPT for select points so that I can select all the points and rather than trying to select them. The other option would, of course, be to try to drag a selection through here. I just have to make sure that I don't select that curve. There we go. And I'm going to put these on their own layer. So let me change object layer. And we'll rename layer 5 to be side 1. And I'll make that current. So now that I have those points, I can select those points, and I'm going to use rotate 3D. So rotate 3D, or I can go up to transform rotate 3D to select it. And I'm going to start at the first point, whatever that point is. I'm going to snap to that point. I'm going to go straight out along the axis here. Then I'll go straight up, and I'll fold all of those points down to the side. So they've all been folded down to the side. Once they're folded to the side, it may be helpful to turn off your contours so you're looking at just these points. You might even want to look at them in the top view. Sometimes that's helpful. And now it's time to create the steps. So I will start at the first point again. I need to turn on my point snap here so I can snap to it. And I'm going to start to draw. So in my case, the first line is straight across because the 2 points are on the same level. So I'll go straight across. Then I need to go down, and I'm going to use my smart tracking to create these steps. So I go down like this. Now, because I went straight across here at the top of the hill, at the bottom of the hill, I don't want to go straight across again. I need to go down by my contour interval. I know what that value is. It was 39.063 feet. So I can specify it, and then I can go across and start my process going back up. So again, I'm just using smart tracking, hovering over the point, dropping down to get the perpendicular line. I could probably turn on perpendicular. That would help. It's doing it anyway. And I'll keep working my way back up. this side. In all likelihood, you guys will end up making a few mistakes on these today. That's okay. We're going to go through and correct them next class. So the point is here just to put the effort in. So there we go. I've finished it. I have my step. There's all of my steps. There's all of my points. I'm going to select all of them. They all are. And I'm going to do the opposite rotate 3D. So I did rotate 3D before and turned them down. Now I'm going to do rotate 3D and put them back up. I could turn the contours back on to help as a guide. I'll go into rotate 3D. Like I said, I picked the first point in the row. There it is. I went straight off in this axis. My ortho's on. And I'm going to go from flat up into the third dimension, like that. Now, assuming I did the rotations correct, this should line up perfectly on my edge, which it does. If I looked at it in the right view here, those should all be a perfect line, which they are. If I look at it in the front view, every single one of the steps should be perfectly vertical. The reason I'm telling you this is because several of you over the course will end up with crooked staircases, right? They'll be diagonal. And once you've done it, and you go back and look at these views, it will not look straight up and down, and then you'll know something went wrong. So that's the first strategy for how to create these, which is a very doable, reasonable strategy, seems rather easy on the surface. The next one that I'm going to show you is harder to do initially, but will save you time in the long run. And so this is a concept called the C-plane, which is the plane in which you're drawing. It's similar to the UCS coordinates in AutoCAD, if you're familiar with those in AutoCAD. The idea here is that when we're working in perspective, the plane in which we're drawing is X and Y. We're looking down on it and we're drawing. So if I were to come over here and start drawing something, whatever I draw would end up being flat in X and Y. If I can change that value so that I could be drawing vertically instead of horizontally down on the ground. And I'll do that by changing what's called the C-plane. So my first point on this side here is right there. I don't actually have to create the points. I just have to identify where to start. There it is. And I'm going to change the C-plane. So the first thing I'll do is come up to perspective. I'll go to this little triangle. I'll go down to set C-plane. And I'm going to choose 3 points. When I do that, my new origin is going to be that first point that I identified right there. It's going to ask me for the x-axis direction. This is pretty easy. I just have to go off in space here. And again, I have ortho on, so it's off in space right there. Then it asks me for the C-plane orientation. This is the tricky one. This is where I need to be able to go straight up and down. So I'll come back over into the front or the right view until I can go straight up and down. So there it is, straight up and down. Not snapping to anything, just straight up and down. When I click, we can then look at that point, and you'll actually see the little grid on plane. That's now my drawing plane. So anything that I draw, rather than being flat up and down, or flat on the ground, is going to be in plane with the edge of my contours. So this makes it really easy. I don't have to do any rotations. I just start at the first contour right there. I come over, bring this back, snap to perpendicular. Go to my next point, bring this back, snap to perpendicular. And you can see that as I'm drawing, it's drawing right in that plane for me. So there's no rotations required. So initially, this takes a little bit of grappling to understand how it's working. However, if you can grasp the idea of a C-plane, it is extremely useful when you're modeling, especially on building elevations and that sort of thing, to be able to switch to draw right on the surface of a wall, for example, just by switching your C-plane. So I'll keep going here. This is again at the bottom of a valley, so I have to go down. It would be negative 39.063 feet. There it is. We'll go across, then we'll start coming back up. That there is at the top of a hill, so we'll go across, and then we have to go back down to right there, and I'll finish. So now that curve was just drawn in place, but it represents the same set of steps that I was working on. When I'm done with the C-plane, this is really important. You need to go back and reset it. So I'll go back to set C-plane, and I'm going to choose World Top, which is what I was working in by default. If you feel like you get off with the C-plane or something didn't work correct or you're kind of wonky, go back to World Top and start fresh. So World Top always resets you back to the standard X and Y axis. Then you can go back once again to set C-plane, 3 points. I'll start on this first point here. I'm going off in this direction. Next one has to go up in the Z direction. There it is, going up in the Z direction. My little grid has shown up. And I can start drawing again. So I'll start at that point and work my way up this side. Down that side, this is 39.063 feet. Over and back up this side. Almost done here. 39.063 feet. Oops. And almost done. Right there. I'm done with this side. So I was able to create these two sides rather quickly. Don't worry about the corners. We're going to talk about the corners next class. Just work your way up each side. Your goal for today is to be able to create these contours and to create all the steps for all 4 sides. If you finish all 4 sides, you're feeling pretty good. That's a good thing. We will revisit the whole thing next class again. I'll start from the very beginning. I'll start with the SketchUp model and I'll bring it all the way through one more time. I'm not expecting you guys each time to go all the way through. You don't have to do it each time. You can start where you left off last time. But it's part of the learning process. I want you to see me do it each time. Okay? So I'll turn you guys loose unless you have any major questions. If you run into a snag, let me know. I'll try to help you through it. Typically, the big things that happen if you're using the C-plane method is you end up snapping and your C-plane is twisted instead of being perfectly flat. So that's one of the big things that people get messed up on. Don't forget to double check in your views that your stairs are all perfectly vertical. I can go back and look in these views to make sure that they are. As long as they're perfectly vertical, you're okay.